All right.
Oh, so it's in 2 boxes.
So a bunch of people mentioned that they attended the Service Fabric session yesterday, so thank you very much. So I'm not going to spend a huge amount of time talking about Service Fabric in particular, but I do want to talk a little bit about kind of how we think about it in depth yesterday around some of the challenges with monolithic applications and why we think that for certain scenarios, microservice-based architecture can be valuable. The way we think about it, though, is that, as I said yesterday, it's really about being an application pattern. So it is a way to build software from a conceptual perspective, a way to architect your application. It is not a specific thing that you're using. There's no test to say, because I'm using this framework, or because I've written this piece of code that I'm now doing microservices, or I've kept my services under 1,000 lines, like I've done microservices. That's not really the right way to think about it. There's a set of concepts that you're trying to apply, and you can use those concepts in any number of different platforms. So you can sort of stitch things together yourself. I mean, you could build a microservices architecture just using base VMs and deploying a bunch of application code to it that are following those principles. A much more common model kind of in this bucket is to use something like a container orchestrator, have the microservices be containerized, and talking to each other and following that through the microservices pattern. But again, just because you're deploying containers doesn't mean you're doing microservices. And kind of as we talked about, functions is certainly an option. They are independently scalable in particular, which is great. But we also think that Service Fabric provides a really good environment for building microservice applications because it balances out that notion of independent scale and independent upgrade with having this cohesiveness of an application model that kind of wraps around it. So, some of our initial marketing material was around Service Fabric equals microservices, microservices equals Service Fabric, and we've sort of expanded that thinking a little bit to really say, hey, there's a number of different ways to do it. We happen to think Service Fabric is one of the better ones, but they're not tightly linked together.
So, quick question: can Azure functions call other?
Yep. I mean, they're just HTTP endpoints. Okay. So.
Question: can the functions be PowerShell scripts?
No, they're HTTP endpoints.
Who came up with the name Service Fabric?
What's that?
Who came up with the name Service Fabric?
Oh, our lovely marketing folks.
Dumb.
Yeah, you'll get no debate from the team on that. So it used to be called Windows Fabric. The internal code name was Windows Fabric. But obviously, since we wanted to bring it to Linux, that wasn't going to be a great name.
Doesn't Azure have some Service Fabric controller or something?
Control, yes.
Yeah, something like that. It's
Yes.
not coming from there, is it?
It's related, but it's not the same. So yeah, it's we basically paid consultants a lot of money to go come up with a name, and it took them months and months and months, and it was getting to the point where we almost didn't have a name before we were going to announce the product. And everybody was waiting with bated breath for them to come back and tell us what the awesome name they came up with was, and it was like, huh. That's what you came up with. Okay. And it's been a lot of fun to do these types of presentations and talk about building Service Fabric services. Which is just, yeah, I don't think they really thought it through necessarily. But, it's at least gotten some traction now. So yeah, I'm not going to go too detailed into into Service Fabric because I want to save some time for more kind of conversation. Let's see. So a bunch of people were at the Service Fabric session. How many people were at the ACS discussion? September as well. Okay. So what are the things that, so I'll spend a little bit more time on the container piece. Not quite as many people were there. Some of the pain points that containers are trying to solve is really around having the ability to take a common package with your application code and all of the associated frameworks and be able to deploy that to multiple environments in a way that is highly consistent. And then also be able to start those pieces of code really quickly, much more quickly than you can do with just a base virtual machine. So containers spin up quite a bit faster than your typical virtual machine, which is part of the answer to why not just use VM. We've been using VMs for a while. They are great for what they do, but it's a fairly heavyweight solution. And so, by virtue of that size, it's kind of hard to move them across environments. You typically end up with not the best density because you have to try to match your application size to your VM size. And so being able to have those smaller, faster to start out, easier to move around containers is quite powerful. And that's where the container service comes in. Now, if you think about the way that we've been sort of stepping through this deck, we're moving down the stack, right? So we started at kind of the app service and functions level. Service Fabric I think of as being a little bit lower than that. And the reason I say that is, while you're taking a bunch of compute and putting it together to provide a place to deploy applications, ultimately that compute still belongs to you. You can go into the portal and see all the VMs that are associated with your Service Fabric cluster. You can log into those VMs. You can install random software. You can go, fiddle with the Service Fabric runtime and make your cluster not work. Like all of that resource belongs to you. And so you have a higher level of control than you would with something like app service, but you also have, in a lot of cases, a higher level of complexity. And there's a lot of work that we're doing to try to sort of soften those edges for anybody that's used Service Fabric. A common pain point at the moment is that we don't give you automated OS patching, for example, which is a huge pain, right? You have to actually physically go into those machines and run the OS update in order to make sure that your cluster stays up. So that's something that we're looking to fix, but that's an example of a piece of complexity that you sort of run into when you're using that sort of middle layer where you still own the resources. That being said, you do get this kind of prescriptive model for building applications where you've got built-in service discovery, you've got these service lifecycle events that you can bind to, you've got the opportunity to use some of the stateful capabilities to write applications, write services that have co-located state and data. And so there is that kind of strong application model that sits on top of that base platform. You get to something like container service, and now basically what you're doing is just taking some containers and deploying them across a set of machines, and the orchestrator, so DCOS or Swarm, will make sure that those containers are balanced based on what resources they ask for, and that they'll keep running. Even if they crash or one of the machines goes down, they'll move those containers around. But those orchestrators have no idea what's inside the container and don't really care. Like, they're not telling you how to write the code that's in there. They're not telling you how those containers talk to each other. Like, all of that is kind of up to you. And so ACS kind of sits at a fairly low infrastructure level. Now, it's interesting in the sense that a lot of these orchestrators have been used as the base foundation for people to build applications on top of. There's a lot of patterns that have emerged on top of some of these base orchestrators because of work done in the OSS space by a bunch of big companies like Netflix and Twitter. So Netflix in particular has released a whole series of open source libraries, including things like Spring, which make it easier to build applications, and those are fairly prescriptive. And they're typically built on orchestrators like this, and so people sometimes think like, oh, this is a platform solution for building applications. Like, well, yeah, if you pull in all of those additional pieces and understand how they work, it is by itself. It doesn't give you that prescriptive model. So again, I'm gonna, since a bunch of people saw it already, I'm gonna skip over the demo. We can do it a little bit later if you want to see it again. One of the things that's interesting about containers, and I mentioned this briefly in the ACS talk, is they're such a powerful concept for being able to take your code and make it highly portable and really performant in terms of being able to spin up, that we don't want to restrict it to just things that are called container orchestrators. We want to take all of the platforms that we offer all the way up and down the stack and make it so that you set up a build pipeline that's going to actually create containers that you can deploy those containers to whatever service you're actually targeting. So whether that's something like app service, potentially something like functions, Azure Batch, all the way down to obviously ACS and Service Fabric. So you can learn some of those container concepts and be able to apply them across all the different services. So this is kind of a North Star for us to drive forward. Associated with that is making sure that continuous integration, continuous delivery is really first class across all of our services. How many people are familiar with the notion of CI/CD? Most people, okay, cool. So yeah, regardless of what tools you're using, we obviously think that VS Team Services is pretty good for this. And I showed a demo of using that with Service Fabric yesterday, but obviously Jenkins is pretty popular as well. And so we're doing things like making sure in the STS that a bunch of the services that you might be deploying to have sort of first class build and release tasks that make it really easy to set up a CI/CD pipeline targeting those services. We're doing very similar things with Jenkins and other CI/CD tools. Last thing I'm going to do is talk a little bit before we get into kind of how I lay out some of the options and how they relate to each other. Is everything that I've talked about so far has been first-party services, with the nuanced exception of ACS in the sense that ACS is deploying a third-party orchestrator, but it is sort of still at the top level of first-party offering. You can run other PaaS solutions on Azure. So we've been doing a lot of work around partnering with a bunch of companies that are driving PaaS innovation outside of Microsoft, and making sure that if that's if one of these is a PaaS platform that resonates with you and works well for your workload, that you can run that on top of the Azure public cloud. And so let's talk a little bit about one in particular. How many people are familiar with Cloud Foundry? Not too many. Okay, so Cloud Foundry, you can think of as being conceptually similar in a number of ways to Service Fabric. It is a clustering technology as well as a way of deploying applications and orchestrating them across a set of machines with a set of services, sort of higher level services provided to make it easier to build applications. And part of the value proposition of Cloud Foundry is that you get that same experience regardless of whether you're running on Azure or AWS or Google or on-prem. And they do things like helping you manage those OS upgrades, for example. So they'll give you, if there's a critical security fix that comes into the base OS that you're using, they'll give you an updated image, and there's tools that can just say roll that image out across my set of machines without taking any downtime. So managing those type of operational tasks in a really straightforward way. So what does it look like for that type of platform to run on top of Azure? Well, we take their code and run it on top of our base resources, as you might expect. And that works fine. It works the same way as it would on any other cloud. But the other thing that we do is take advantage of a concept in Cloud Foundry which is called service brokers, which allow applications that are running inside the Cloud Foundry cluster to create services that are sort of part of their marketplace and then bind to those services. And so we've built a bunch of brokers for the Azure specific services, so that if I'm a Cloud Foundry app and I want to use, say, table storage or service bus or a SQL database, I can easily create with a couple of command line calls the associated service and then bind it into my app so they get all the connection string information and properties that are required to connect to that thing from my application. So this is where kind of the third-party piece that's sitting inside the green box becomes tightly integrated with the services that we run. Then we also do, because inevitably things will go wrong, we do integration with Pivotal's support. So regardless of whether you have an issue with the Azure cloud infrastructure or the software that's built and delivered by Pivotal, you can talk to either your support team and that'll get resolved sort of behind the scenes. And this is just kind of an example of how we're taking those third-party platforms and making so they're not necessarily at the same level of integration as some of the first-party offerings, but it's also not like it's just, well, you're on your own, like you deployed some stuff, like good luck. It's somewhere in between. Okay, so let's walk through this list, some of which I covered, some of which I didn't. And then I'm kind of curious to get people's thoughts on kind of the positioning and how much it makes sense or not. So I didn't really talk about the pieces at the top because they're more in the IaaS bucket, but they are options, and they're obviously options that people are using quite a bit today, so it'd be good to include them in the list. How many people are familiar with the analogy of pets and cattle with respect to compute resources? Okay, not too many. So I'm not actually sure who coined this, but the idea is that traditionally when you deploy infrastructure either in your own private data center and it really continued on into public cloud, was that you had these very specific machines that oftentimes had names that you would, I remember one company I worked at named their machines after rivers of the world, right? Or you have them named after animals or cities or something. And they're very specific machines that have very specific software deployed on them. Maybe there's a backup of each of those machines, but you have an idea in your head of okay, there's the Thames machine that is 4 cores and has 8 gigs of memory, and then there's the Nile machine that's whatever configuration, and each of them has this stuff deployed on them. And if I want to set up a new environment, I need to set up an environment that looks the same way and has those types of machines. That sort of maps to the idea of machines as pets. Pets typically have names, and you love them and you hug them and you feed them and you keep them happy, and you're very sad when they die. In the same way, you're very sad typically when those named VMs or physical machines die. Even if you have a backup, there's probably some work involved to get it up and running and get it sort of back online. There's a lot of management involved in that kind of model. So the idea of this sort of pets and cattle analogy is we want to try to get to the point where we're dealing with the machines as cattle, where they're all kind of indistinguishable. You don't typically give them names. If you lose one, you replace it with another. And it's not really that big a deal. I'm not sure how cows feel about this analogy. They're probably not that excited about it. But it kind of makes sense where ideally you just have a bunch of these sort of ephemeral VMs that are running some software. And if one of them goes down, hard drive dies, whatever, gets pulled out, another one starts up, gets the software deployed automatically, and things keep running. And you can load balance traffic across those VMs, and you don't have to think about what's running where with a lot of specificity. So base VMs are sort of a solution for the pet kind of situation where you want us to take your on-prem topology with specific machines and specific deployments on them, move them to the cloud. Huge amount of our business is that. It's great. It's just a lot of management. VM scale sets kind of starts to move you towards cattle in the sense that it is an auto-scaling group of identical VMs. And so you have the same set of software deployed on each of those VMs. They scale up and you load balance across them. But there's still no real application layer that you're interacting with. It's just you can scale up the same machine. Azure Batch is kind of a specialized service focused on parallel computing. So jobs that you want to be able to spin off a whole bunch of compute at once to complete. So that one typically doesn't get too muddled in this whole conversation. And then we get into some of the ones that we talked about. So the container service, as I think I alluded to, is really about, you've got a set of containers, you want to deploy them and manage them on a Linux cluster. Actually, this is something I didn't mention in the ACS talk. But ACS is currently, the orchestrators below ACS are currently only supporting Linux as a GA offering. Docker Swarm has Windows support. It's still in private preview, I believe. So you're deploying a set of containers. In terms of an application, though, it's sort of up to you to figure out how you want to stitch those things together. So if you're up for that, it's a fine solution. Service Fabric, by contrast, much more of a Windows-focused offering today, which is why I think there's typically a lot of interest when we come to these types of events where there's a lot of Windows developers and IT pros. If we are bringing it to Linux, obviously, but it's going to take some time both for it to get to be GA'd on Linux as well as for it to develop kind of the community associated with being a Linux offering, right? Today, if you search for Service Fabric, search for samples or guidance, such as there is, even that is a little bit nascent, but basically everything you're going to find is going to have Windows screenshots, .NET code in it. And so if you're looking to build microservice applications on Windows using Visual Studio, Service Fabric is a great option. And then app service and functions kind of at that top level of the stack, I think are really well suited to the scenarios that they're targeting. But you do have to keep in mind kind of the constraints that come along with that. And so, as I mentioned at the beginning, if you can target the top level of the stack, if that works for your scenario, I think that's usually the best place to start. And then think about, okay, if there's certain constraints that are being placed on me at the top level that force me to move down to lower levels of the stack, then start to move down gradually until you get to a point where you feel comfortable. But don't start at the bottom. Okay? And then the third-party offerings, typically what we see is that customers are the ones that come to us asking about those. They've gotten into Kubernetes or Cloud Foundry or OpenShift or one of these offerings kind of their own accord, or somebody has been trying to sell it to them and they want to just run it on Azure. So those are typically not things that we are going out and pushing to people, but we are trying to make sure that they work really well on our platform. Does this make sense? People feel like they kind of rock what option to use when? Is there still confusion, yeah.
Did we have the slide if at all relative to the Microsoft Office?
With the what, sir?
Like pivotal?
Yeah.
What would you put up, like, besides specific fabric, little?
Yeah, so as I was saying, I think it's around this level. In the
It's a little more than that, right?
What's that?
Pivotal, those are more than.
Yes, certainly around on the operational side, they make things a little bit easier. Also, the thing that they do that we don't necessarily want to push from a marketing perspective is I would say their cross-cloud, their sort of portability across clouds is much better than something like Service Fabric. Like Service Fabric, you can run on any cloud, but it runs much better on Azure because it's built on top of VM scale sets, for example, and you can go through the portal and set it up. Whereas when you're setting it up on-prem, there's a different model for setup and management, and so there's some of those aspects where it's a bit of a step down. Whereas Cloud Foundry, because they're not tied to any particular cloud, they make sure that experience is consistently pretty good across these different offerings.
What's the difference between
you had mentioned using kind of the highest level technology you can,
Yeah.
unless it's going to be too limiting.
Yeah.
What's the easy, quick way to find out what those shortfalls are going to be? What's going to bite you?
Yeah, so probably the best resource in terms of an all-in-one kind of capturing that is currently this, which is unfortunately a fairly long document. It's about 30 pages that covers all these different services and kind of what they do and what the constraints are. We are actively working on a more kind of bite-sized version that would be something like the previous slide, but would also have the constraints and kind of what the real sweet spot of those services is, so that we're very upfront about hey, on app service you don't get to log into the machines. Is that cool or not cool? Which, I mean, again, it's kind of the nature of things a little bit for teams to not proactively go out and tell people what they can't do, right? And so you kind of have to discover it yourself. So that document does cover a bunch of those things. We're working on making a better version of that. There was a question over here.
Yeah, so what's that virtual machine that's set and the cluster? What's the difference between
Virtual machine scale set and cluster?
Yeah.
Well, so a scale set is basically just you define some VM image, and then you can stamp out a whole bunch of those images that are identical. And then typically we just put a load balancer on top of that, and you split the traffic to pass the traffic to any one of those.
You have to retro load balance, or what do you do?
The load balancer gets configured automatically by setting up a scale set. But a cluster allows you to have a bunch of machines that know about each other but can have different software deployed to them. So I can have an instance of service foo on one of the machines, and service bar on another one of the machines, but they're all clustered together in the sense that they know about each other. If one of them goes down, then the one that's running service foo goes down, then the cluster is able to self-heal to say, oh, I need to make another copy of foo and run it on that machine over there. So it's a little bit of a smarter set of machines versus just a bunch of cows, basically.
Where do the Power Apps fit in this?
Power Apps would be sort of at the top level sort of app service or even higher. Power Apps, Logic Apps, things that are targeted at sort of business users being able to create applications without writing any code or just a little bit of code. Very much at the top of the stack. You're definitely not logging into VMs at that point. I guess I should have said the other thing that at the top of the stack limits you on, in addition to the ability to log into the VMs and fiddle with those, is to some extent you're betting on Azure, right? Because you can't, if you're running say Service Fabric or one of the ACS orchestrators or something like Cloud Foundry, you can easily just have that environment and take it and set it up in a different cloud. Azure App Service doesn't exist in any other cloud, right? There's sort of like equivalent services or competitive services, but it's not like I can just necessarily turn around and redeploy. At least I can maybe from an application perspective, like if I've got an ASP.NET application, I can just redeploy it to another kind of hosted auto-scaling thing. But if I'm thinking about like, how do I operationalize it, and if I want to connect it into a particular VNet, like that kind of stuff, you're sort of tied into the way that you set that up in Azure.
Is a Power App, how to put it? It is better than if you were to develop from app service up.
Power Apps, what do you mean by that?
Power App is for business users that don't need to write code, yeah? So let's say I compare that with one where I try to build something similar.
Yeah, I mean, it's the next level of abstraction, right? So if you're able to build your application using Power Apps without having to write any code, that seems great, right? Like if you don't need to drop down and start writing code, then don't do it, right? It's just like anything else. You're trading off control and power for, ironically, you're trading off power to get higher productivity. And it sort of depends on the skill set of the person building as well, right? If the person doesn't write code, then obviously any of the solutions that involve them writing code are not going to be good options.
So currently, how many users using Linux on Azure, and how many using .NET?
So we're right now at about 1/3 of our VMs are Linux. Of our kind of steady state, but we're actually seeing it's around half of new VMs. So it's actually Linux growth is outpacing Windows growth at this point.
Do you have an offering similar with Facebook GraphQL? They say they go above the rest, dealing with web services. Yeah. I mean,
REST.
Yeah,
you don't use REST APIs, you mean?
Yeah, REST APIs. Yeah, they are abstracting them with the GraphQL APIs.
Okay. Yeah, I'm not familiar with GraphQL, so I'm not really sure what to compare it to.
Okay, thanks.
I just have a question on the container service. I tried to attend the session, but
Sorry, you can't ask that question in this session.
no.
Go ahead.
I'm gonna ask it anyway. So if you've got a bunch of VMs, and I'm talking like Docker containers now,
Okay.
and say for all of our practice, containers consume a certain amount of memory and a certain amount of CPU. Is there a flexible way that that the system will actually scale things for you automatically, so that if, for instance, I have one VM and all of a sudden more jobs come in,
Yep.
it can actually add more containers to that VM, and then when that's used up in some way, it creates another VM and it starts populating those containers.
Well, so there's two different things. There's app level auto scaling, which is basically adding more containers, for which there's no built-in support in those container orchestrators. That's like in the demo that I was showing. There's a piece of code that is like a custom piece of code that's doing that query and calling an API to scale it up. So you can use something like that to do the auto scaling of the number of instances running in the cluster. But you're still, at that point, you're still limited to what is the base compute resource that you have underneath, right? At some point, you only have so many cores and
Yep.
amount of memory. And so that's where the VM scale set piece comes in. So ACS, the orchestrators are built on top of, or at least the agent nodes are built on top of VM scale sets. And scale sets allow you to set metrics at the physical resource level that will trigger scale up or scale out or scale in of the number of VMs in the scale set. So that'll allow you to have more compute resources, because at some point, if you just keep cranking up the number of instances of an application, you'll run out of resources. and those jobs won't get scheduled anymore. And so at that point, you would want to add more actual.
Yeah. What I was kind of looking for is some sort of scaling of the containers as well as sort of scaling inside one VM as well as scaling across, across the number of instances like that.
Yeah,
Based on some custom rule set that if you know what your container does and how much you can predict how much resources it's going to be taking, then you can kind of make smart decisions about that, right?
Yeah, so they end up being two different concepts that you kind of have to work together, because the orchestrators are built so that they can run on a discrete set of machines, right? They need to be able to run in an on-prem data center where you don't have elasticity. So that they have that's the scaling piece at the application level, and then once you layer that on top of something specific to a public cloud like scale sets, or like in AWS, auto scaling groups, that's where you can kind of make them work together such that once that scaling at the application level hits a certain threshold, which ultimately results in a certain amount of physical resource usage underneath, the scale set itself starts to scale out, and then you get that additional pool. That the orchestrator will then go, oh, okay, I've got these additional machines now. Let me expand out and let those containers breathe a little bit. So yeah, there's no, sort of by design, that the orchestrators are not in the business of trying to spin up additional VMs, because there's most of the environments that they run, they wouldn't be able to find them. And if they don't have that, there's no API they can call to get Bob in IT to go get them an additional machine.
If I only have a web application
Yep.
looking for a hosting server, is that worth to put on Azure? Because it feels like the Azure has more complex functions. So if the application, just the web application,
Yeah.
so compared to other company hosting server, how about the price, or what kind of benefit I can get from Azure?
Yeah, so I'm probably not in the best position to speak to the details of pricing, certainly relative to competitors. I can tell you that Azure App Service has a free tier. So depending on the level of load on your web application, it's possible that you don't have to pay anything. So you can have a fairly lightweight web app there for free. So that's nice. And then I think the thing that's valuable about putting your app in something like App Service is that you have the ability to grow it up to take advantage of some of those additional features. Even if today you just want to deploy it and have it be stood up and people can hit it through the browser, maybe down the line you want to take advantage of some of the additional insights capabilities, or connect it up to a CI/CD pipeline. All of those integrations are quite nicely done, which in a lot of cases is possible with just a web hoster, but it's all kind of nicely integrated. You go through the portal and you see all these different options that you can configure. But yeah, it kind of comes down to what is the scale of your app, and go look at the pricing for app service. But as far as I know, it's pretty decently competitive.
It's cheap
What's that? It's cheap?
compared to the
There you go.
not even negative.
That,
Price.
that's kind of what I figured.
There is a way to limit for Azure functions. Like for example, like spam. Somebody's keep accessing it and gonna cost you a lot of money. How can you, because each time it's a call, you are charged.
Yeah.
There is a way to put a filter or
Cap your spend.
There is I'm not super familiar with the detail on the constraints piece of functions, but as far as I know, there is a way
like a firewall in front of it. Don't call the function if it's like you make a VPN or something like that. To limit that only from this.
Yeah, definitely. I'm not familiar with whether functions out of the what functions provides out of the box for that, but that's a case where something like putting API management on top of it would allow you to do rate limiting, for example, to have that as kind of your ingestion point, and use that.
Then you lose the whole advantage of function if they are not.
No, because that's just a translation and forwarding layer, right? You're not actually writing code in there. That's just the
And that's a VM or what? What's
no, it's a PaaS service. So you just set up an API management service, and then you set up the mapping from what API you want to expose publicly into the individual functions. So that's a pretty common pattern.
Thank you very much. It was
Okay.
an awesome session.
Thanks, everyone.
Actually,